Okay. So let's think about proving things. There are specific things we have to do. There are rules we have to follow. When proving things about a shape, there are a few things to keep in mind. We will need to use the information or use the distance formula, to prove information about side lengths. So if I'm saying something's a square, I should be able to show all sides are equal. So I'll have to use the distance formula to do that. So I could find the distance of each side and be like, well, I used the distance formula and all sides came out to 8.25. Well, all sides are then equal. The slope formula will be able to tell us a few different things. If the slope of two lines are equal, we know those lines are parallel. That's going to be very helpful in proving something. So parallelogram, let's say, when I say opposite sides are parallel, is an important property. Well, we'll have to use the slope formula to help show the opposite sides are parallel. So if I got two sides that both have a slope of 2, I can conclude that those two sides are parallel. We can also show that things are perpendicular or meet at a right angle with slopes. So if you multiply two slopes together and get -1, we know the lines are perpendicular. If you get anything else, they meet at a different angle. So if I multiply two slopes together, like say I had a slope of 2 and -1/2, that multiplies to give me -1. So when I multiply and get -1, that tells me they meet at a right angle. So right away, I'm seeing right angle. Let's see. I know a square, all angles are right angles, so that could come in handy there. Rectangle, all angles are right angles, could come in handy there. Give me a second, it hasn't been 15 yet. Good morning, do we have this? We also know, like say in a kite, the diagonals cross at a right angle. So there are different places we could be looking for that. So I see a few people still writing. This is important information. It is posted online. I'll give you a minute to copy this down while I fix up a student's attendance. So these are important properties to keep in mind. We're also going to talk about, this is how we're going to use the formulas. Next 2 slides, we're going to talk about what properties we're going to look at for each shape, because each shape, you're going to look to prove different things about it because it has its own unique properties. And again, those are properties you looked at the other day in that Desmos activity where you were just making observations, like noticing like, oh, when a kite, the sides next to each other are the same. Oh, when a trapezoid, that one was the weird one, like nothing really seemed to match up. So we're going to physically look at the shape and kind of go like, hey, it looks like it's this. Use that as your starting point, as your hypothesis, so to speak, and then collect the evidence to see if it is or not. Sometimes it may look like a certain shape, but then the evidence says it's not. We're going to go with what the evidence says, not what our gut says. I heard somebody knock. rhombus. Again, these notes are posted. And still see a few people writing off the board, so give them a second, and then we'll look at properties. We'll first do, I think I have square, rectangle, and I believe parallelogram is the third on the next slide. And then kite, trapezoid, and I believe rhombus is the last one on the slide after that. Might have been out of a different pack, or might have been like the first one out of it or something. Yours might have been later.
Now, your car chemical, did you smell it? I don't know. You got this for the office. Yeah, like,
I was in the bag.
yeah.
I thought you meant somebody.
But you know how the last smell you first get from the office, I don't like that smell.
Yeah.
Okay, so some things to remember here. Remember, for a square, we should be able to show that all sides are equal and all angles are right angles. So that's going to involve both using the distance formula and the slope formula. We'll look at that in action. Remember, for a rectangle, we should be able to show that opposite sides are equal and all angles are right angles. Remember, for a rhombus, we should be able to show that opposite sides are equal and opposite sides are parallel. So all of these are talking about using both slope and distance. For the square and the rectangle, for the right angle, you'll have to multiply slopes together to see if you get -1 to show that those sides are perpendicular. And you'll have to use the distance formula on all of these to show the different side lengths. With a rhombus, all we have to do once we get the slopes is show that the opposite ones are the same slope. And in doing so, we can then, well, we can claim they're parallel because we've taken the time to provide the evidence to show that they're parallel. So our evidence is key here. So just telling me a shape is something isn't good enough. We need to provide the evidence that backs that up. Again, I know a few people are copying here. I am sorry for those that are watching the recording. Remember, you can just kind of fast forward a little bit through these pauses while students are writing. No, that would probably be too small. The next three shapes we're going to look at are parallelogram, kite, and trapezoid. Now remember, you're going to have to find the distance of each side. So in one problem, you'll have to do the distance formula 4 times. You might have to do the slope formula 4 times. That's why we practice and make sure, like, yeah, I know how to use slope, distance, and midpoint formula before we got into this. I want to make sure we had that down. So that's not going to bug us down. Sorry. That's okay. So now that we've got those formulas down, that shouldn't trip us up too bad while we're doing this work. I know a few people are still writing, just so you get this down.
This is on Schoology, right?
Yes, it is posted on Schoology. The completed notes aren't up yet because we're working on them right now, but all this is already written in the black notes. I know a few people already have that up on their screen right now and are kind of using that instead of looking at the board. Okay, now for the next three shapes. For a parallelogram, we need to show that opposite sides are equal. So that will be utilizing the distance formula. And we need to show that they are also parallel. So I see that's slightly different up here. So opposite sides are both equal and parallel. Kind of extended it out when I said it, but same idea. So again, to show they're parallel, going to use the slope formula, and we should get 2 sides match and 2 sides match. Same with the distance formula. We should get opposite sides are the same with the distance formula. Remember, for a kite, we should be able to show that adjacent sides are equal, so that will utilize the distance formula, and that the diagonals cross at right angles. So here with that, again, we're looking for about 2 properties of each because there are so many overlapping properties. Like if I just said opposite sides are equal, how do I know that's a rectangle or a rhombus, or not rhombus, a rectangle or a parallelogram? That's why we'll use that second property in there to help distinguish them. The last one, trapezoid. If you suspect something's a trapezoid, we should be able to show that only one pair of sides is parallel. So for a trapezoid, you only have to use slope. You can just use the slope of all 4 sides and be like, oh, these 2 are parallel, the other 2 aren't, it's a trapezoid. That will provide your evidence. So we'll get that down, and now I got a few examples for you. So we're going to build up in how we do this. The first few examples, I'm going to give you all the information. Then we're just going to say, okay, we have the information. What should the shape be? How do we know it? The later examples, we're actually not going to have all the information. We're going to need to find that information using either slope, distance, or midpoint formulas, and then write our conclusion. All this is really getting at. Here's how we're finding evidence. Here's where we're digging for it. Here's how we're figuring it out. Let's take a look at the first example here. So example 1, it says, is this a rectangle? How do we know? So let me actually make that a little bigger for us on the board. There we go. So, is this shape a rectangle? So it looks like it. What evidence do we have that it is a rectangle? Yeah, okay, so opposite sides are equal. I got 12 and 6 here, good. Or sorry, 12 and 12 here, 6 and 6 here. So yeah, opposite sides are equal. One piece of evidence. What's our other piece of evidence? Because that applies to both a rectangle and a parallelogram. What's the other thing that helps distinguish it as a rectangle? The angles are all right angles. So we provided the evidence. We're explaining how we know. So to answer this, is this a rectangle? How do we know? Yes, it is a rectangle. Because you guys provided the evidence that opposite sides are equal. And you guys pointed out the evidence that all angles are right angles. And all angles are right angles. It is critical we write this statement. This statement here is our evidence. It is our proof. It is explaining why we know. It's not important that we know that it's a rectangle. It's more important we know why and how it is a rectangle. That evidence is key here. And this is explaining that. So like when you write an essay, you just don't say something without explaining it, right? Proofs are the same way. We can't make a claim without backing it up. Okay, so we'll look at another example like this where I give you the shape and it's just going to be like, oh, okay, you just have to figure out what it is. Then the last one we're not going to have. Yes. Yeah. For the last one, we're not going to have all the evidence we need right away. So we're going to have to use slope distance and midpoint to try and get the evidence we need. Okay, I think we're done writing. Let's take a look at the next example. Oh, this is rather small. Let me blow that up. Trying to get it as big as I can for you guys. Okay. Let's start off. Does this shape look like a parallelogram? Yeah, I'd say so. Let's see what evidence we have to it. What do you guys notice inside this shape? What can we conclude right now with what's being stated on it? Let's look at the sides first. What do we know about the sides? Good. So this is a slope of 0. This is a slope of 0 here. They're parallel. This is a slope of 2. That's a slope of 2. So we have opposite sides are parallel. That's great. What other piece of information do we have? Opposite angles are congruent as well. So since opposite angles are equal and opposite sides are parallel, we can then conclude that this is a parallelogram. Now, oftentimes we won't be dealing with measurements like this in the corner. We'll be looking probably more like slope and distance, but this one changed it up a little bit on us. Not a big deal. So we did conclude that this is a parallelogram. So yes, it is a parallelogram. R's come before the L's and parallel. Because opposite sides there's an E in sides. That's SIDS, sides. Opposite sides are parallel. And opposite angles are equal. So there is our evidence. There is no shadow of a doubt that this is a parallelogram based on the evidence we provide. We have now proven it. And again, like I said, proof is key here. Now proof, we don't believe you. It's that simple in math. If you don't provide the proof, the evidence, how do we know it? We've got one more example that's going to be a little more in depth. It's going to be more like your work for today. But before we go on, did this make sense? How we can look at the shape and be like, okay, here's my evidence. Is there any question about how we're writing our conclusions here based off of what we see? Cool. So now let's take a look when we're not given as much evidence. This is really faded. I am so sorry for those of you looking at this on the board. It was darker on the PDF. It's probably looking better on the Zoom. I'm going to add in the details here. So here is my shape. I'm told these are right angles. So I'm already given some information. I know this point here is 3, 1. This point is 5, 3. This point is 3, 5. And this point is 3, or sorry, that point's off. This point is 1, 3. So right away, what evidence do I have? What's my given evidence? What do I know right now? Is there anything we know about this shape? It has all right angles. That's my given. So that's information I already know. Let's write that down. All angles are, let me actually write that a little smaller. All angles are right angles. So that's a piece of information I already know, and it's saying the shape kind of looks like a square, right? That's a property of a square, so I'm off to a good start. What else do I need to know about a square? What's special about those 4 sides? Well, that would be the angles, and we do have that. But in a square, what do we know about the 4 sides? Does make a quadrilateral. What's special about the length of the 4 sides in a square? They're the same length. That is not a piece of information we currently have, right? However, if we know the points, could we use the distance formula to find the length? Yes, so we're going to have to utilize the distance formula 4 times here to prove all 4 sides are indeed the same length. So I'm just going to start. I need to look at the actual PDF. Give me 1 second, guys. I just need to, I forgot to label these. I forget which ones. I think it's A, B, C, and D. But I want to make sure it is consistent with what it actually says on the PDF when we can read clear. Oh, almost had it right. So this is A, B, C, and D. So what I'm going to do is I'm going to start with the length of A to B. Using the distance formula, show what that is. I'm going to go B to C, C to D, and D to A. Okay, so again, distance formula is equal to left x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to utilize that 4 times. So first, the length of AB. So that is the points 1, 3 and 3, 5. Remember, x1, y1, x2, y2. Let's just work on plugging this in. So that's the square root of x2, which is 3, minus x1, which is 1, squared, plus, now y2, 5, minus y1, which is 3. parentheses squared. Now, remember, I said we could just utilize the Desmos calculator. Just as long as what I put in the calculator looks just like this, we'll be good. Desmos calculator. There we go. Again, square root of 3 minus 1 parentheses squared plus, yes, I have my parentheses, good, 5 plus 3 parentheses squared. So this, oh, I said 5 plus 3, it should be 5 minus 3. Not a big deal. I just go in and edit this to a minus 3. There we go. So we get 2.828, so that 8 would round that up to a 3. So 2.83 is my distance here. So I'm going to also write this up here that I now know that this is 2.83. We'll repeat this process 3 more times. I have AB, now I'm going to go systematically through. I'm now going to hit BC. So BC is the following points. It's 3, 5, and 5, 3. Then I can label it X1, Y1, X2, Y2. I'm going to just take the time to plug in. So this is again going to be the square root of X2. That's 5 minus X1, which is 3. Quantity squared plus, then I go Y2 minus Y1. Thank you very much. That's going to be 3 minus 5 quantity squared. So all I'm doing is plugging in the distance formula. That's why I was like, yo, we need to get these formulas down before we go on to today's lesson. This way, today's lesson, we're like, oh yeah, I know how to use the distance formula. We're practicing it the last 2 days. So again, I'm just going to type it in how I wrote it. Parentheses 5 minus 3, close parentheses squared, plus 3 minus 5, close parentheses squared. And hey, cool. This matches up as 8.3 again, or sorry, 2.83 again. So far, 2 are matching up. That's looking good for us. Our evidence and what we see with our eyes are indeed aligning. It looks like a square, but we need that evidence. You can't just say it looks that way. Okay, so I did A, B, B, C. Let's go on to CD. CD says I have the point 5, 3, and the point 3, 1. So again, this is X1, Y1, X2, Y2. So let's start plugging in. It's going to again be the square root of X2, that's 3. Oh, I wanted to write down a 3. Sorry about that. Minus X1, that's 5. Quantity squared plus, now Y2, that's 1. Minus Y1, that's 3. Quantity squared. Again, take the time to type this into the Desmos calculator. So let's see, I get it so I can see what I wrote, and I can do it if I do it this way. Let me resize this very quickly. Oh, there we go. So again, starts off square root of is 3 minus 5 quantity squared plus 1 minus 3 close parentheses squared. So, okay, cool. 2.83 again. It looks like it's all lining up, but we still need that fourth side here. So right now we're at 3 out of the 4 sides are equal. We just need to show the evidence that the last side is equal to. So now let's go to that last side. It doesn't matter what order you go in. I'm just going to say I like going alphabetical. I'm going to call it side A, D. If you wanted to call it side DA, it doesn't matter. The distance, the length of it is the length, regardless of what order you do it in, right? We already talked about the idea. We don't talk about negative length. So the distance formula actually prevents you from getting negative answers. With it being a square root, square roots always are positive unless we're dealing with imaginary numbers, which I don't think we talk about imaginary in IM2. I want to say that's all IM3 and pre-calc. So I had the point 1, 3 and the point, good morning, Mr. Engel. Oh, thank you very much. Definitely use some water this morning. Okay. So X1, Y1, X2, Y2. Here with this, again, I'm just going to plug in to the formula. So it starts off, again, we're doing the same thing again. Square root of, now I need to do X2 minus X1, so that's 3 minus 1, close parentheses squared, plus, now Y2 minus Y1, Y2 is 1, minus 3, quantity squared. Let's quickly type this into the calculator. And my guts tell me we should get, again, that 2.83, but we actually need to put it in and see. So negative, or sorry, quantity 3 minus 1 squared plus, it says 1 minus 3, close parentheses squared. Here we go, 2.83 again. So we showed that all 3 or all 4 sides are indeed equal. I do need you to show your work of what you're doing with whatever formula you're using. This way we know what it's going on. So this is all my evidence. Now I need to write my conclusion. So this shape is indeed a square. Entire page. There we go. So this is a square. How do we know it's a square, though? What properties did we just prove? What was our given information? What information was given to us here? We have all right angles. What information did we just prove? All the sides are the same length. So this is a square because all angles are right angles and all sides are the same length. This is a square because angles are right angles and all sides are equal. So we provided that evidence. So you guys will have about 20 minutes left in class to get started on the work. I'm going to stop the recording. Stop share. Stop recording.